I'm Peter Mildon. I'm the Chief Operating Officer and one of the co-founders of Viva. We're a ITS company providing an intelligent sensor to provide anonymous data on how road space is being used. It's all about empowering the people that manage that space to make it more efficient, safer, easier to use by the general public. So the sensor's video-based, so it's got a camera in the device, but it's also got a GPU processor that is extracting that anonymous data at the edge. So that means there's no personal data leaving the device. We understand where the pedestrians are, where the cyclists are, where the vans are, how they're moving around, how close they are to each other, how many are going past, and that's the data that's then really useful to understand that space's usage. So imagine you have a cycle lane. We can work out how many cyclists are actually in the cycle lane, how many are on the sidewalk, how many are choosing to go in the main traffic, and that really starts to tell you about how that piece of infrastructure is being perceived by the population. We've trained it to recognise, at the moment there are 9 classes of road user. We're actually aiming to grow that to about 31. The rarer the class, the harder it is to train because it learns by seeing. So if they're less common, it's harder for us to train it. But at the moment, we're accurately detecting your pedestrians, cyclists, motorbikes, cars, vans, so small commercial vehicles, pickup trucks, those sorts of things. 2 types of heavy commercial good vehicle, whether that be rigid or articulated. So here in the US, it's a semi-truck would be the articulated one. Everything else falls into the rigid category. And public service vehicles, so buses, school buses, those sorts of things. E-scooters, being the one that I missed in all of that. Very important one, and one of the most recent ones that hit our minimum threshold. Before we publish a new class, we've got to get to 90% accuracy in the count. We won't tolerate something below that. So cyclists operating 97, 98%, e-scooters have reached that 90% threshold for us to publish it. The device weighs about 1.5 kilos. We say that's the same as 2 pigeons, so it's really lightweight. All we need is power, so if you've got street lighting already there, we can just plug straight into the power socket and that's it installed. So I've been doing a project recently with the New York City Department of Transportation, and they've been able to install them themselves, really quick and easy. We provide remote support and the sensors are set up within an hour of getting onto site. So it's been a nice, easy process for them. In terms of what the New York City DOT have been using the data for, they've got their new Open Streets initiative, where they're really trying to improve how road space is being used by pedestrians and cyclists, making a shared space, removing the concept of jaywalking at some junctions so that the pedestrians can walk across and the vehicles are driving through at a slower speed. And we've been trying to prove 2 things for them. 1, that the behaviours are changing in the way that they think they should be, and 2, is that actually safer? So that's a really good time to talk about the latest feature that we're launching here at ITS America, our near-miss capability. So on that capability, effectively, the camera is looking for interactions that might be unsafe. So is that a cyclist getting too close to a vehicle or a vehicle too close to a cyclist, whether they are moving quickly and therefore occupying the same bit of road space very quickly after each other, or indeed, if they carried on in the same direction, would they have crashed? So 3 easy ways for us to measure safety, and that gives a data output that is consistent from site to site on how many near misses are you getting as a good predictor then of incidents in the future.
It's a 2D image, but the AI creates the 3D perception.
Absolutely. So we've got a single camera, it's not stereoscopic, and from that single 2D image, it's really important for us to understand the outline and edges of the 3D vehicle. Imagine if you draw a 2D box around a vehicle, you don't know where its side is, so how close has it got to that other road user, be it a cyclist or an e-scooter. So we've trained the AI to actually not just detect the vehicle, but work out its height, length and width, and that gives us its footprint on the road. So we use then some clever trigonometry to work out where that actually is in 3-dimensional space, and that's how we measure the distance between those vehicles. So yeah, some pretty clever maths sitting in behind it. But the important part is it spits out a really reliable measure of how safe the road interactions were. We've produced some interesting case studies off the back of that of road user behaviours that can then instruct how to improve safety at that particular site.